Hi everyone. Now we will study counters. We have already seen what is register. Register is basically an bit storage device. We have already seen different type of register like shift register, and there are many other parallel in, parallel out. Okay, so many type of registers we have already seen. Now what is a counter? This is another sequence circuit and this is very useful in digital circuits. Okay, so what is a counter? Let's see. Counter is basically a register that goes through a predetermined sequence of binary states. Okay, so this is the definition of counter. The definition is very simple. Counter is basically a sequential circuit. It is simply a register that goes through a predetermined sequence of binary states. Okay, so for example, you can notice we have already seen what is a register. For example, register is basically an bit storage device, and we have already seen what is a shift register. Okay, now what is a counter? Counter is basically a sequential circuit which goes through a sequence of states. Okay, which goes through a predetermined sequence of states. Okay, with example this point will be clear, but the definition is very simple. So you can notice a sequential circuit that goes through a predetermined sequence of states. Okay, so that is your counter. This is called counter. Okay, so let's take some examples and let's see now. Okay, so you can notice again, because counter is a sequential circuit. Actually, sequential circuit, there are many sequential circuit. What is a sequential circuit? The definition you already know. Sequential circuit means basically a circuit in which we remember, basically a circuit in which the output depends on the present input and also the past inputs. Okay, so you can notice the sequential circuit. So we know what is a sequential circuit. This is a circuit in which the output of the circuit that depends on the present input and also on the past inputs. Okay, so basically you have to memorize something. Okay, so in the sequential circuits we have memory element, and the basic memory element is flip flop. So I can say that basically sequential circuit is basically circuit with a flip flop. Now there are many different type of sequential circuit we have. For example, register. This we have already seen. What is a register? And okay, now we will study counters. So basically many different type of sequential circuit we have depending on their application, depending on what they do. For example, what is a register? Register is basically n bit storage device. If you want, for example, 64-bit storage device, if you want, then you can use 64-bit register. Okay, and we will study what is a counter. Counter is a sequential circuit which goes through a predetermined sequence of states. Okay, so basically this counter will go through a predetermined sequence of states. Okay, so this type of behavior counter has. And okay, many other sequential circuits we have, for example, sequence detectors and and many more. Okay, so this we have already seen. This register we have already seen. This is what we are going to study in this lecture. Okay, so now with example this point will be clear. But remember, counter is a sequence circuit, so this counter also can be represented using state diagram and state table. Okay, because any sequential circuit, we have already seen that whatever sequential circuit you have, that can be represented, behavior of this sequential circuit can be represented using state diagram, also using state table. So I can say that counter is a sequential circuit which goes through a predetermined sequence of states. Okay, so this type of sequential circuit is called counter. Okay, now let's take example and let's see what is a counter. For example, you can notice if your counter, for example, this is a counter. Okay, you can notice this is a counter. Why? Because this goes through a predetermined sequence of states. Okay, you can notice if your counter is in this state 000, then next state will be 001, next state will be 010, next state will be 011, and so on. You can notice that this counter is basically it is doing like this. Okay, this counter is going from 0 to 1 to 2, okay, to 3 to 4 to 5 to 6 to 7, and then from 7 to 0. Okay, so this is your counter. Okay, now this type of counter is called binary counter, because you can notice that this counter is going from 0 to 7 and then from 7 to 0. Okay, so this counter is basically binary counter. This is a 3-bit binary counter. Okay, you can notice this is a 3-bit binary counter. Now, okay, anyway, this type of counter which goes through this type of sequence, that is called binary counter. For example, what is a 4-bit binary counter? I can say that 4-bit binary counter. Okay, so what that will be? You know what is a binary counter? Binary counter definition is very simple. Now let's see what is a 4-bit binary counter. That simply means that you have, okay, 4 bits, and the next state will be 0001, the next state will be 0010, the next state will be 0011, and so on and so on, and then okay, finally Okay, here you have 1 1 1 1, and then you have like this. Okay, so you can notice this type of counter, this is called binary counter. This is a 4-bit binary counter, this is a 3-bit binary counter. Okay, so similarly you can say what is a n bit binary counter. Okay, so let's see what is n bit binary counter. N bit binary counter, this is a sequential circuit. Remember, n bit binary counter, this is a sequential circuit which goes through this sequence of states. So this is a binary counter. What it means, this is n bit. Okay, so I can say that this will actually go from 0, then 1, then 2, then 3, and so on. Okay, to power n minus 1, and then it will, okay, go to 0. Because you can notice what is happening here. I can say this is 0, this is 1, this is 2, this is 3. Okay, this is 15. So you can notice 0 1 2 3 and so on 15, and then again 0. So this is your 4-bit binary counter. This is your n bit binary counter. So n bit binary counter, that will go from 0 to 1. Okay, 1 to 2, 2 to 3, and so on, like this. Okay, so this is a type of, this is your counter because it goes through a sequence of states. Okay, it goes through a predetermined sequence of states. So this is a binary counter. Now you can notice, look at this counter. Okay, this counter, what this is doing, this is a down counter. Okay, this is just opposite of binary counter. You can notice that binary counter, if you notice, okay, the binary counter that goes like this. For example, if I see 2-bit binary counter, then it will go like this. Okay, from 0 0 it will go to 0 1, from 0 1 it will go to 1 0, from 1 0 it will go to 1 1, and from 1 1 it will go to 0 0. So this is a 2-bit binary counter. Now look at this type of counter. Okay, for example, okay, look at this type of counter. For example, I can say which will go from 1 1 it will go to 1 0, from 1 0 it will go to 0 1, from 0 1 it will go to 0 0, and from 0 0 it will go to 1 1. Okay, so you can notice this counter. If you notice this counter, it is doing like this. Okay, it is doing like this, that from 0 it is going to 1, from 1 to 2, and then 3, and then 0. So this is your 0. Okay, 0 to 1, 1 to 2, 2 to 3, and then 3 to 0. So this is your 2-bit binary counter. Look at this counter, what this is doing. This is doing like this. Okay, so this is actually 3 to 1 0. So this counter is doing like this: 3 to 2, 2 to 1, okay, 1 to 0, and from 0 to 3. Okay, so you can notice if this is 2-bit binary counter, then this is just down counter. This is up counter, you can notice. Okay, from 0 to 1, 1 to 2, 2 to 3. So this is your up counter. And okay, so, and this is a down counter because this is going down from 3 to 2. Okay, then 1, then 0. Okay, so this is called 2-bit binary down. Okay, binary countdown counter. Countdown counter. Okay, so this is the name of this counter, you can notice. Okay, so here you can notice that this counter, if you notice, this is going from, okay, so here I can say that, okay, this is going from 7 to 6, then 5, then, okay, then 4, then 3, then 2, then 1, then 0. Okay, so this counter is your binary countdown counter. Okay, so anyway, I am just telling you different type of counters. For example, this is another counter. Okay, just remember the definition of counter. Counter's definition says that a counter is a sequential circuit which goes through a predetermined sequence of states. For example, this is also a counter because you can notice this sequential circuit goes through a predetermined sequence of states. Okay, in this counter you can notice what is happening. Okay, you are going from 0 to 1, 1 to 2, then 3, then 4, okay, then 5, 6, 7, 8, and 9, and then again 0. So you can notice this is decimal counter. The name of this counter is decimal counter because this counter, what this counter is doing, this is doing the counting from 0 to 9. Okay, so from 0 to 9 and then 0. So you can notice this is your decimal counter. Okay, let's see another type of counter. This is another counter. Okay, in this counter you can notice that, again you can notice this counter is basically like this. Okay, once you are in this state, if you are in this state 0 0 0, then the next state will be 0 0 1, next state will be 0 1 0, like this. Okay, so this is your counting sequence. Okay, but remember, if your counter is in this state, if you start in this state, if this is your initial state, then the next state will be 0 0 0, next state will be 0 0 1, next state will be 0 1 0, like this. Okay, if your initial state is 0 1 1, then also next state will be 1 0 0, next state will be 1 0 1, like this. Okay, so this is another type of counter. Okay, you can notice the definition of counter. You should remember counter basically means that this is a sequential circuit which goes through a sequence of states. Okay, so this is another example of counter. In this counter, you can again notice that this is the counting sequence. This is the counting sequence. Okay, because remember, if you start in this state, then what will happen? If you start in this state, then the next state will be 0 1 0, next state will be 1 0 0, next state will be 1 0 1, like this. Okay, so if you start in this state 0 1 1, then the next state will be 1 0 0, next state will be 1 0 1, like this. Okay, so this is another example of counter. This is another example of counter. In this counter you can notice that, okay, okay, if you are in this state, if you are in this state 0 0 and your input is 1, okay, here you can notice that you have some input also. Okay, so if you are in this state 0 0 and let's assume your input, okay, so let's assume your input x is 1, then you will go to state 1 1. Okay, if you are in this state 0 0 and if your input is 0, if your input is 0, then you will go to state 0 1. So again you can notice that this is another example of counter, because this is also going through a predetermined sequence of states. Okay, and depending on the input, for example, in this state, if input x is 1, then you will go to state 1 1, and if input x is 0, then you will go to state 0 1. Okay, so this is another example of counter. This is another example of counter. Here also the same thing. Okay, you have input, for example, from this state. Okay, if you are in this state, let us assume you are in this state, and if your input is 1, then you will go to state 0 0, and if your input is 0, then you will go to state 1 1. Okay, so this is how, okay, this is another counter. Okay, and this is another counter. You can notice in this counter what is happening. See, if you are in this state, let's assume if this is your initial state, if, okay, then the next state will be this, then next state will be this, then the next state will be this, like this. Okay, but let us assume your initial state is this, then the next state will be 0 0 0, next state will be 0 0 0, like this. Okay, so similarly, if your initial state is this, then the next state will be 0 1 1, next state will be 1 0 1, like this. Okay, so we have seen many examples of counter. I hope the definition of counter is clear to everyone. Counter simply means that this is a sequential circuit which goes through a predetermined sequence of steps. Okay, predetermined sequence of states. Okay, so this is a very simple definition of counter. Okay, so this is the definition of counter. You can notice a sequential circuit that goes through a predefined sequence of states. Okay, so like this, from state S1 to state S2, then S3, then S4, then Sn, and then S1. Okay, so this is the definition of counter. Okay, now let's see type of counters. Now there are two type of counters that we have. One is synchronous counter, another is asynchronous counter. Okay, so what is a synchronous counter? Synchronous counter simply means that all the flip flop, they basically, okay, they are triggered by the same clock, or I can say that, okay, all the flip flops, they are clocked at the same time. Okay, so all the flip flop, they are operated by the same clock. Okay, but in the asynchronous counter, okay, in this asynchronous counter, I can say that different flip flop, okay, for example, okay, with example this will be clear. Basically in synchronous counter, what happens that if you have a synchronous counter, then in synchronous counter, if you have three flip flop, let us assume these are the three flip flop, then they basically they share the common clock. Okay, so they all share the common clock. Basically they are operated by the same clock. Okay, so the same clock will affect their working. Okay, so this type of counter is called synchronous counter. I can say that all the flip flop, they work in a synchronized manner. The same clock will basically affect their working. Okay, now what is a asynchronous counter? Asynchronous counter, in this asynchronous counter, actually this happens that, okay, to this flip flop we apply the clock. Okay, so this clock only is this clock is applied to only this flip flop. Now what happens that the output of this flip flop, the output of this flip flop is basically working as clock for the next flip flop. Okay, similarly I can say the output of this flip flop is working as the clock for the next flip flop. Okay, so like that. Okay, the output of this flip flop, the output of this flip flop will work as clock for the next flip flop. Okay, so this type of counter is called asynchronous. So this is the definition of synchronous and asynchronous counter. You can notice in the asynchronous counter, I can say that the clock input of all the flip flop, they are not triggered by the same clock. Okay, basically I can say that the clock of a flip flop, that is basically the output of the previous flip flop. Okay, so this type of counter is called asynchronous, and this type of counter is called synchronous, because here all the flip flop, they are synchronized by the same clock. The same clock is applicable to all the flip flop. The same clock is basically operating on the same basically all the flip flop, they are operated by the same clock. But here you can notice the clock is only this flip flop is operated by this clock, or by the input clock. Now you can notice, okay, this flip flop is basically operated by the clock okay, which is the output of this first flip flop. I can say the output of this flip flop is basically working as the clock for the second flip flop. The output of second flip flop is working as the clock for the next flip flop. Okay, so this is the this is the idea of synchronous and asynchronous counter. Okay, now you can notice, okay, look at this counter. Here we have two flip-flop, and you can notice that the same clock, okay, so this is your clock. Now the same clock we are applying on this flip-flop, and the same clock is also applicable on this flip-flop. I can say that these two flip-flop, they are operated by the same clock. Okay, you can notice this same clock is okay, triggering this flip-flop, and this same clock is triggering this flip-flop. Okay, so I can say this is your synchronous counter, because all the flip-flop, they are synchronized by the same clock. And you can notice in this example, you can notice the clock, okay, the clock is only, okay, triggering this flip flop. You can notice only this flip flop is operated by this clock, by the input clock. But you can notice the output of this first flip flop, okay, this output, you can notice this output is working as the clock for the next flip flop. So this type of flip flop, this type of counter, this is called asynchronous counter. Okay, so this is the idea of synchronous and asynchronous counter. Now remember, in general, okay, for counter we have seen that we have two type of, okay, so counter we have seen that there are two type of counter. I can say that there are, okay, synchronous counter, okay, and there are asynchronous counter. Okay, so we have seen. But remember, in general, any sequencer circuit, whatever sequencer circuit you take, okay, any sequencer circuit, you can have, okay, sync, okay, the basically in general sequencer circuit can be divided, can be categorized into two, okay, two categories. One is synchronous sequencer circuit, another is asynchronous sequential circuit. Okay, so you can notice this is the idea. Now what is a synchronous and what is a asynchronous sequencer circuit? Let's see the definition. But okay, what I am saying is we have already seen that counter, okay, counter can be categorized into two types, okay, synchronous counter and asynchronous counter. Now I am saying that in general, the sequential circuits, they can be categorized into two categories. Okay, so we have two type of sequential circuit. One is synchronous sequential circuit, another is asynchronous sequential circuit. Now what is synchronous sequential circuit? The name itself is telling you that basically this everything is happening in a synchronized manner. Okay, okay, so this sequential circuit is synchronous if everything is controlled by a clock. Okay, so basically in these sequence, in these synchronous sequential circuit, I can say there is a clock which controls everything. Okay, so everything is happening, okay, in synchronization with the clock. Okay, so this is the idea of synchronous circuit. Okay, now you can notice in this synchronous sequential circuit, the states change in synchronized manner with the clock pulse. Okay, and what happens in this asynchronous? In this, whenever you change the input, then the output will change. Okay, so as soon as you change the input, the output will change. Okay, so this is the idea of synchronous and asynchronous sequential circuit. Okay, so remember the point is like this. Okay, for example, you have a circuit. Okay, let's assume this is your circuit. Now in this circuit, if, okay, let us assume you are changing the input. Okay, so let me change this input. For example, maybe this is a D flip flop. Okay, now if I change the input, then you can notice that if, okay, there is a clock. Let's assume that all the flip flop, they are triggered by the same clock. Okay, so this clock is operating on the same on all the flip flop. Now you can notice one thing, that if you change the input, it does not matter if you change the input, but you can notice, okay, when the clock will go, if all the flip flop are positive as triggered, then I can say that when the clock will go from 0 to 1, okay, in that case the output of the flip flop will change. Okay, I can say this is the point. Okay, so you can notice that this circuit, if you notice this circuit is working in synchronized manner from with the clock. I can say that if the clock is controlling this behavior of this circuit, whenever this clock will go from 0 to 1, okay, then in that case the output will change. Okay, if the clock is, okay, for example, during this duration, okay, just look at this. Okay, let's, okay, so if the clock is going from 0 to 1, at this time your circuit will act, your circuit will do the normal operation. Okay, but you can notice during this period, okay, just look at this period. During this period, even if you change the input, okay, let us assume you are changing the input, even if you change the input during this period, then nothing will happen. Okay, so you can notice this circuit. If you notice this circuit is the behavior of this circuit is controlled by the clock. Okay, so this is the idea. You can notice the state change in synchronized manner with the clock pulse. So this is the example of synchronous sequential circuit. Okay, now what is a asynchronous sequential circuit? In the asynchronous sequential circuit, whenever you change the input, the output will change. Basically, you don't have to wait for the clock. In this circuit, you have to wait for the clock. Let us assume you are changing the input. You are changing the input. Now, okay, for example, okay, this input you are changing from 0 to 1. This input you are changing from 0 to 1, and this input you are changing from 1 to 0. If you are changing the input, you also have to wait for the rising edge of the clock. Okay, if all the flip-flop, let me assume that all the flip-flop are positive edge triggered, then you can notice if you are changing the input of the flip-flop, then you have to wait for the rising edge of the clock. Okay, without this rising edge, okay, the output will not change. Okay, so this is called synchronous sequential circuit. Okay, in the asynchronous sequential circuit, what happens? In this asynchronous sequential circuit, what happens? In this happens that whenever you change the input, okay, then output will change. So that's the point. Okay, so as soon as you change the input, then automatically outputs will change. Okay, so you can notice in the asynchronous sequential circuit, as soon as you change the input, then output will change. Okay, so basically there is no clock. There is no clock which will control the behavior of this asynchronous circuit. Okay, so in this asynchronous circuit, you can notice that in this asynchronous circuit, we don't have any clock which will control the behavior of the circuit. But in the synchronous sequential circuit, there is a clock which will control the behavior of the circuit. Okay, so you can read the definition. In asynchronous sequential circuit, the output of the circuit will change as soon as the input will change. But you can notice in the synchronous system, what happens that, okay, the behavior is controlled by the clock. Okay, so if you change the input, the output will not change unless the clock is, okay, basically the clock is triggering. Okay, so the clock will control the behavior of this circuit. Okay, so this is the idea of synchronous and asynchronous sequential circuit. Okay, in the next lecture we will start asynchronous ripple counters. Okay, so basically this asynchronous counter, the another name is ripple counter. So remember, both are same. Okay, asynchronous, this asynchronous counter, this is also called ripple counter, and we will see in the next class. We will also see why these are called asynchronous. We will also see why these are called ripple counter. Okay, so everything we will see in the next class. Okay.